Morning. So today we're looking at sheet 8, a continuation, of course. Now we did up to question 11. We did question 11A. So we start from 11B. So 11B, cos 87 plus cos 33 is equal to sine 63. So we need to show that. This is sheet 8. Question 11B. We are showing that cos 87 plus cos 33 is equal to sine 63. Show. Now we understand that if you are doing the expansion of cos A plus B, we get cos A plus B minus sine A sine B. And if you are doing the expansion of cos A minus B, you get cos A cos B plus sine A sine B. So if we add cos A plus B plus cos A minus B, so we get the right hand side, cos A cos B minus sine A sine B plus cos A cos B plus sine A sine B. So you see that this part and that part gets cancelled. So this is just giving us 2 cos A cos B. Now, if we let x to be A plus B and maybe y to be A minus B, I'll bring it down here, y to be A minus B. So you can simultaneously solve for A and B. That means that if we do the addition, we're going to have x plus y is equal to 2a, divide by 2, divide by 2. So a is x plus y over 2. If we did a subtraction, then we'll get x minus y to be 2b, x minus y, and then divide by 2, divide by 2. So b will come out to be x minus y over 2. So when we go back to our question, we'll say that a plus b is x. So we're now dealing with cos x plus a minus b is y. So we're dealing with cos y. This must give us 2 cos a has been discovered to be x plus y over 2. And cos b is x minus y over 2. And so we go back to our left-hand side and get cos 87 plus cos 33. This is equal to 2 cos 87 plus 33 over 2 cos 87 minus 33 over 2. This is 2 cos 37 plus 33. We get 120 over 2 cos 87 minus 33. We get 54 over 2. This is the same as 2 cos 60 cos 27. So you do the division there, but cos 60 is half. Because 27 we don't know. But half times 2 is 1. So we just get cos 27. And what else do we know? We also know that looking at where we are going, if we introduce 90, because when 90 meets cos, it gets to 0. Let's try and see if we say 90 minus 27. What do we get? 90 minus 27 is 63. So it would be a good option if we said cos 27 is the same as cos 90 minus 63. Because we know that 90 minus 63 then will be 27. Since when we subtract this, we get 63. And then do the expansion of cos 90 cos 63 plus sine 90 sine 63. Now cos 90 is 0. So we get 0 by the unknown cos 63. Sine 90 is 1 multiplied by sine 63. So this is 0 here. 1 by sine 63, we get sine 63 degrees, which is our right hand side. So we have shown the equality without having to evaluate those two guys. So last time on A, I remember we suffered a lot. We had to do the solving this side and on the right. So if you apply the sum to product, you easily get the solution. Okay, we go back the tutorial sheet and look at how we proceed. We are now on question 12. Express sine 3x in terms of sine x only. Express sine 3x in terms of sine x only. So what is sine 3x? So B is going to be, that was question 12. Sine 3x. Now 3 is one thing that we all know that can be obtained by adding 2 and 1. But if you try to add 2 and 1 for sine, you automatically get the expansion of sine plus cos 2x sine x. Now expressing this in terms of sine will mean that I don't know. Okay, see, the sheet has gone. Okay, so it must be expressed in terms of sine x only, meaning that the power should be 1. So not in a double angle form. So we again expand. What is sine 2x? It's the same as sine x plus x, giving us sine x cos x plus cos x sine x. These are the same, so you can add them and get this. So while the sine 2x will bring in 2 sine x cos x multiplied by this cos x plus the cos 2x, again, we do the expansion. Cos 2x is the same as cos x plus x, which is cos x minus sin x sin x. So we get cos squared x minus sin squared x. So that here we have cos squared x minus sin squared x sin x. Then we expand, so we get 2 sin x. Cos is cos squared x plus cos squared x sin x minus sin 3x. From there, we change cos to sine using the identity cos squared x plus sin squared x is equal to 1. So that is 2 sin x, 1 minus sin squared x plus 1 minus sin squared x sin x minus sin 3x. Then we expand, we get 2 sin x minus 2 sin cube x plus sin x minus sin cube x minus sin cube x. Then add like terms. So we have 2 sin x plus sin x. We'll get 3 sin x minus negative 2 sin cube x minus sin cube x minus sin cube x, we get 4 of them. This is in terms of sine without the double or triple angle, which is what we're asked to do. Seems like life is becoming easy as we go down.
Excuse me, sir.
Right,
Can you kindly repeat the second last part?
The second last should be this one. Is it?
Yes.
So here you're just adding like terms. So since you have sin x here, sine x here, you add the coefficients. 2 plus 1, 3. Since you have sine 3x here, sine 3x here, sine 3x here, you add the coefficients. -2 minus 1 minus 1. So you get -4.
Okay, good. Thank you.
Okay. Let's look at what is coming next. Question 13. Find all the solutions.
Just repeat the slide just a bit, sir.
Okay. So first we read this question. Find all the solutions of the following equations. 2 cos x minus 1 is 0. So you need to choose questions to go and do there. With questions here, you can't do all of them. So either you choose one, I choose one, or you choose both. If there's no choice, I'll make
H.
H.
F.
What else?
F.
H and F. So we'll start with H, then F. Or we'll start with yeah, I'm going to want to talk
Even D, sir.
but you said both. You can't do all of them. There's so many. So the slide, those who wanted the slide is here.
Okay, thank you, sir.
Okay. Question 13. D. Sec x 2 cos x minus √2 is equal to 0. This is the product on the left equated to 0. So we split the product, equating it to 0. 2 cos x minus √2 is equal to 0. But sec x, this guy is 1 over cos x is equal to 0, which is not possible. So no solution from this. Then the other side, we take this other side, we have 2 cos x is equal to √2, divide by 2, we'll get cos x be √2 over 2. Which angle x gives us √2 over 2 for cos?
45.
45. So x is equal to 45. This question is so open that we don't know what the next thing is. So you don't know like how many angles you should bring out. So you can also go in the fourth quadrant and pick an angle there where cos is positive. So what is 45 in the fourth quadrant? The issue of reference. So you get 315. This means that depending on the angles needed, we can keep on adding or subtracting in looking for terminal angles of 45 and 350. And 315. So we suspend, we leave it here. We have found at least 2 angles since there's no interval given, but there could be so many from coterminal angles. So we go to This is 12 or 13. That was D. F. F tan 5x minus 9.
What's the conclusion there?
The conclusion is that x is 45 and x is 315. Since there's no interval given as to how far we should go in terms of finding x, like in question 14, we find there's an interval given. Now, when the interval is free, you can just find within 0 to 360. Though there could be so many.
All right.
It's also possible that you can say, okay, I'll say 45 plus or minus 360 n, meaning the first coterminal you multiply, you add 360. Second coterminal, 360 by 2, 360 by 3, or you subtract like that. So here you have 315 plus or minus 360n. All these will be solutions to this, because they are coterminal and coterminal angles have got the same behavior, same properties. Then f tan 5x minus 9 tan x is equal to 0. Wow, tan x is common and will remain with tan 4x minus 9 is equal to 0. Meaning that tan x is 0 or tan 4x minus 9 is 0. Now when tan x is 0, which angles? The zeros of sine, 0, pi, 2 pi, meaning that it's 2 pi n for n running from 0, 1, keep going. Or we can just say plus or minus, plus or minus. So for n, 0, plus or minus 1, plus or minus 2, because we're not given how many angles we should give, which interval of angles. But we know tan will be 0 wherever sine is 0. So that is sine over cos. Now tan 4x is equal, minus 9. This is a guy like this one. You can say tan squared x minus 3 tan squared x plus 3. So tan x is equal to root 3 and tan x is equal to negative 3 root. So of course here no, but here you have plus or minus. When is tan x root 3? Which angle? You guys don't know the angle.
60.
Not 30.
Okay. If I've forgotten, I
Or
can
it's
check.
east.
So you can check sine 30 cos 30. So the top one is half, the down one is root 3 over 2. So this is 1 over root 3. So it's not the 1, so it's 60. So x is equal to 60. So where tan is positive, that's the first quadrant, and the third quadrant. The third quadrant is 180 plus 60, giving us 240. Then where tan is negative, in the second quadrant, 150 minus 180 minus 60, 120. In the fourth quadrant, 360 minus 60, 300. So you can just find within the first circle. If you want a variety of them, keep going around. Then that was DF. The first choice was not yet been answered. First choice
Excuse me,
was
sir, there where you read my pi is where, and on the last part where there is tan squared minus 3. Kindly repeat that statement.
but my pies are here. We are getting for tan x to be 0. For tan to be 0, x must be either 0, pi, or 2 pi. Now there's no interval of how many we should bring from which value of x to which value of x. So we are free. Now if we are free, we can see that for as long as we are multiplying 2 pi by some number n, we'll be able to get, in fact, not even 2 pi, just pi n. Yeah, this is n pi. Exactly. For n, 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, we'll be getting n pi. Pi is 180. So you'll be getting n by 180. The second part, this can be written as the difference of two squares. If you write tan squared x power 2 minus 3 power 2, like this. Difference of two squares. So you pick the inside minus 3, the inside plus 3, and then you get to 0, you get to 6. Then you get the solution. So that's how you come out of this question.
X squared come from?
From tan, we are given tan 4x. Tan 4x is the same as tan squared x power 2. Okay, x4. Suppose tan is x. X4 is the same as x squared squared. Is it okay?
Yes, sir.
Okay. Then going down, then it's okay still. All right. Next, say J. Oh, H. 4 sin x cos x. 4 sin x cos x plus 2 sin x minus 2 cos x minus 1 is 0. So many things. At least here we can see that 2 sin x is common. So you factor out 2 sin x and we remain with 2 cos x plus 1. At least here we can see that negative is common. So you factor out negative 1. You remain with 2 cos x plus 1. Then we have a common thing inside. So we factor it out. And get that.
So
Hello.
there I will do a negative 2. There is 4 sine x in the question.
Yeah, right.
Is it
4
even
sine
supposed
x.
to be
4 sine x cos x. Then we are dividing it by 2 sine x. This sign will cancel that one. This 2 will reduce that 4 to 2.
no? I thought maybe we have another sign inside.
So why I can't see is why you're calling the part you're calling inside. Okay, then this guys are equal to 0, so you equal to 0. So you get cos x is equal to negative half, and sin x is equal to positive half. So for x to be half, it's 60 for cos. Now it's negative, so it's not this one. You go for where cos is negative, so the 60 in the second quadrant, which is 120. The 60 in the third quadrant, which is 240. Then for x, for sine, you get 30 in the first quadrant, and then 150 in the second quadrant. And this is not the solution. This is part of the working. So this was h. Hello.
So I didn't get it. Just on the second step there, where you said 2 sine x, open bracket 2 cosine. When you divide like the way you did on the other part of the board, you have cancelled the sine x. Then where has this sine x, which is outside the bracket, come from? Because you have cancelled the whole x side when dividing into 4.
If I have x4 plus x squared is equal to 0, and then factorize, how do you factorize? You pull out x squared and then start dividing. X4 over x squared plus x squared over x squared, so that you get x squared plus 1. That is what you call factorizing. Now that we have 4 sine x cos x plus 2 sine x, we factor out 2 sine x, meaning we must divide every part by 2 sine x. 2 sine x over 2 sine x. So the 2 sine x is there. Then this one divides up here. We get 2 cos x. This one divides up here. We get 1. So that if we are to expand back, we'll get this one.
All right, sir. All right. Thank you.
Then we go to time out. Question 14 is
Sir.
solved as question 13. They're exactly the same.
Excuse me, sir. For the sine, you just solved the in the second quadrant, not in the first quadrant, where sine is positive.
150.
I'm saying in the first quadrant.
State.
Okay, thank you.
What about for course?
For course, it's fine. It is second and the third.
Alright. Okay. So I'm saying question 14 is exactly what we are doing in question 13. So that's your baby there to next. So that in our next session, we'll look at the graphs of these functions. So we'll look at 15, 16, 17 in the next session to be communicated. There's a class for some people I'm told very, very soon at 6:50. So enjoy your class and have a good day. The video will be uploaded.
Sir,
Hello.
how many TGs are here?
There are 5.
All right.